Hello everyone. In this video we are going to look and explore direct variations. So I'm going to start you off with the question, what is a direct variation? Direct variation is when y is directly proportional to x. A lot of words, but let's see what that means. The direct variation equation is y equals k times x, and k is just like the rate, the slope, right? So the k is the constant, right? Similar to y equals mx plus b, where m equals the k and b has to be equal to 0. Just remember, a direct variation goes through the origin, goes through 0, 0, no matter if it's a graph, an equation, or a table of values. So let's look at the three different views. We have direct variation on a graph. Easy. This is probably the easiest out of the three. The graph shows a direct variation. It goes through 0, 0. All right, if it goes through 0, 0, it's a direct variation. And right there, when you're talking about that 0, 0, where it crosses that origin, goes through the origin, has to be a straight line going through the origin. That means y-intercept is 0. It's a direct variation. An equation of a direct variation is y equals kx. It's the same thing as y equals m times x, right? Where y-intercept must be 0 and the k, which is the m slope, must be constant. Remember, it has to be a straight line. So an example I have down right here is y equals 3x. So the slope here is 3 and the y-intercept is 0. As long as the y-intercept is 0, that means you have a direct variation. Because that y-intercept is 0, the constant is 3, that's it, direct variation. The most difficult out of the views to identify is the direct variation of the table, because a lot of people forget it. So this equation, y equals kx, can be solved for k like this, and it is equal to k equals y over x. If you solve for k, you're dividing by x on each side, and you get k equals y over x. If you divide the y value and the x value, right, the y value by the x, and you come out with the same constant, that means you have a direct variation. So, you see this 6? You see this 3? 6 divided by 3. 6 divided by 3 is 2. This is the k. So k equals 2 here. 10 divided by 5, k equals 2. 14 divided by 7, k equals 2. And then 18 divided by 9, y divided by x. Again, k equals 2. This is a direct variation. Right? Remember, in order for it to be a direct variation, they should all have the same k value. And since the k is constant, it's the same for every point. We could find k when any given point dividing the y coordinate by the x coordinate. And that's it. Let's get on to some problems. Recognizing a direct variation on a coordinate grid. Does the graph below represent a direct variation? Well, let me see. This is the first thing that you do. Let's identify the y-intercept. The y-intercept is where the line crosses the y-axis. Here's the y-axis, goes down right here. That's where it crosses the y-axis. And this is 0, 0, 1, 2. So the y-intercept is 0, 2. Y-intercept is 2. So this is not a direct variation. I'm going to put not a direct variation. And the reason why it's not a direct variation is simply because this linear function does not cross the y the 0, 0, the origin. It crosses at a y-intercept of 2. Has a y-intercept of 2. It crosses that y-axis at 2, 0, 2. Does this graph represent a direct variation? Well, let me go and put a point there. Yes, it does. Yes, this is a direct variation. And this is the reason. It crosses, this linear function crosses at the origin. And simply put, this does not cross at the origin. This is not a direct variation, crosses there. And this is a direct variation because it crosses there at the origin. And that is it as far as the graphs go. Recognizing an equation of a direct variation. Well, an equation of any linear function is y equals mx plus b. Right? So the b of a direct variation must be 0. Has to cross at that origin. So let's identify the b. These are all y equals mx plus b, except for these. You'll have to do some work with them. But, all right, the y-intercept is 6. This is not a direct variation. And the reason why? Crosses at 0, 6, not at the origin. What about this one? What's the b? Well, the slope is -4. The b is 0. Direct variation. Well, then when you're not in y equals mx plus b and you have to solve it, it's a little bit more difficult. But there's a trick. Do you see this number right here without the variable? Well, if you're looking at that number and it's not 0, then this is going to have a y-intercept of another number, right, other than 0. So there will be a y-intercept here of some other number. It's not going through 0, 0. This would have to be 0 for it to go through 0, 0. So let's go ahead and solve. If we solve for y, we subtract the 2x. We have to get the y alone. All right, we're going to say this is not a direct variation. Look what happens. We have 8y equals -2x plus 16. And then we're dividing 8 on both sides. And look what happens. We have y equals -1/4. I'm reducing it. All right, reducing that fraction. And 16 divided by 8 is 2. The y-intercept is 2. This is not a direct variation. But I could tell that from the beginning. It's important to know how to solve for y. But I could tell that from the beginning that this was not going to be a direct variation. This number must be 0. Look at this. So I'm going to say right off the bat, this is going to be a direct variation if we solve it. But it's a direct variation now. This line, solve for y equals mx plus b, will have a y-intercept of 0. Let's see if we can do that. So I'm going to minus x on both sides. Look what happens. Since there's 0 on the right-hand side, we just have -x. We don't put plus 0. Right? So we divide by 2, and then you get y equals, and just want to make you understand, there is a 1 that is in front of every x. It's understood, right? But when there's a negative in front of the x and there's no coefficient showing, it's -1. So we're just going to keep that fraction. You see this fraction right here? This is -1/2. So that's what I'm going to put, -1/2x. And this is a direct variation. Direct variation. All right, that's it. Let's go on. So we have identifying a direct variation from a table of values. So we have a table of values here, and we're going to look, and we're just going to divide the y and the x to see if the constant is the same. So we're not going to do it for 0 and 0 because you can't divide by 0. But let's go on to the next one. What is 10 divided by 5? That's 2. What's 20 divided by 10? That's 2. 30 divided by 15? That's 2. This is a direct variation. The constant remains the same. All right, the k is the same throughout. So let's go ahead and do this. This is y, this is x. 12 divided by 2, so far, 6, good. 35 divided by 5, so far, wait a minute, 7. Not a direct variation. You don't have to check the rest of them. Not a direct variation. Constant does not remain the same. Let's check that third one out, and we're going to do the same thing. Y divided by x, 4. 12 divided by 3, 4. Check all of them. 20 divided by 5, 4. Direct variation. And that's because the constant remains the same. So we went over graphs, coordinate grids, equations, and tables. Each very easy to identify if it's a direct variation or not. Hope the video helped, and thank you for watching.